Welcome to the 2018 Actuarial Research Centre's webinar for the Modelling, Measurement and Management of Longevity and Morbidity Risk. This programme is jointly funded by the Actuarial Research Centre, the Society of Actuaries and the Canadian Institute of Actuaries. This is the second webinar in the series this year, and I'm delighted to see we have viewers joining from all over the world. My name is Gordon Wood. I'm chairing this afternoon session. I'm the Life Board of the Institute of Faculty and Actuaries representative on this programme. The Actuarial Research Centre is the Institute of Faculty and Actuaries network of researchers around the world, which seeks to deliver cutting-edge research into various programmes to address some of the significant global challenges in actuarial science through a partnership of the actuarial profession, the academic community and practitioners. Delighted to be joined this afternoon by two presenters. On my right, Dr. Torsten Kleinau, and on my left, Dr. George Streftaris. Torsten is an associate professor at Heriot-Watt in Edinburgh, and he's an expert in statistical modelling and computational statistics, particularly researching at the moment stochastic mortality models for multiple populations. He's a member of the Life Research Committee of the Institute and Faculty of Actuaries and acts as an examiner. George is, beg your pardon, I've done this again, another associate professor at Heriot-Watt. His expertise is in Bayesian statistical modelling, particularly with applications in actuarial science and epidemiology. He's a co-investigator on this programme, and again, modelling, measurement, longevity and morbidity risk in particular. So without further ado, I'd like to turn to Torsten for the first presentation. Thank you, Torsten.
Thank you very much, Gordon. Good afternoon, everyone. I would first like to talk very briefly again about the research project that we are a part of. And we would like to thank our sponsors, of which we have three: the Institute and Faculty of Actuaries, the Society of Actuaries and the Canadian Institute of Actuaries, who help us to carry out this research. The research team consists of a number of people, which you see here on the slide. We have Andrew Cairns as the principal investigator, and then Angus MacDonald, George, who's here today with me, and myself. We are all at Heriot-Watt University, but we also have some links to other universities in the UK and in other parts of the world, as you can also see on the slide here. Okay. I would now like to move on to presenting some of our findings, of our early findings in this research project, and I would like to talk about mortality and deprivation today, and we will actually start with the second part, and the second part of this title, with the deprivation. And I want to introduce just very briefly what measure of deprivation we use in our work. Okay, and we are looking at the index of multiple deprivation, which is published by the British government. And the idea here is that different aspects of deprivation, mostly income and employment, but also other factors like education, health and crime, are combined into one index, which allows us to give, or allows the government in general to provide a very good measure of deprivation overall. The data on the index of multiple deprivation are collected for around 30,000 so-called lower layer super output areas in England. It's just over 30,000 of them. So those are small geographic areas of roughly the same size. And for each of those areas, the data are collected on income, education, employment, and so on. And an index is constructed, and then those areas are ordered from the most deprived areas to those with the lowest income, the lowest levels of employment and education, to the least deprived, which are those areas with the highest income, the highest achievement in terms of education, and the lowest crime rates. And once those 30,000 areas are ordered, we can split them up, cut them into 10 equally sized pieces, and we have 10 deciles then, where we have the 10% most deprived on one end and the 10% least deprived on the other end. Okay. And the UK government is providing here a little illustration which I want to share with you in this talk. So here we have a map of England, and we find that the least deprived areas in yellow, and in blue we see the most deprived areas, and all the green kind of shades are in between. Okay, so this is a geographic kind of breakdown of those areas. Okay. Now what we are interested in is a link between deprivation and mortality rates, and then life expectancy also. Okay. So the data that we use in our study to understand how mortality rates are maybe different for different socioeconomic groups is we look at data for the mortality in each of those 10 deciles. So we look at the 10% most deprived areas in England, and look at the mortality data, consider the mortality data for those areas, but we also consider the mortality data then for the next 10%, next 10%, next 10%. So that we have 10 groups, and for each of those we have the mortality data. We look at the age range from 40 to 89 for the years 2001 to 2015. Okay, and that's summarized in this slide. The source for the data is the Office for National Statistics, where those data can be obtained for us. Freely available data set, so I would invite everybody maybe to have a look and try your own statistical analysis on those data. Right. So what is the quantity of interest? Well, to illustrate our findings, I want to concentrate today on the death rate, which we define as the number of deaths per 1,000 lives. The death rate is clearly age dependent. There are more deaths at the age of 70 than there are at the age of 50 per 1,000. Okay. The death rate depends on the calendar year. It is different in 2001 for 65-year-olds, say, than it was in 2015 for 65-year-olds. But also we want to look at the death rate specific to IMD deciles, so to the level of deprivation that people have. What we then observe are those death rates for the different IMD deciles. And we know, as a kind of common knowledge, which you can say read about in all the usual newspapers and on the BBC, and so we know that the most deprived have higher death rates than the least deprived. They have a lower life expectancy than the least deprived, and the general rule of thumb is the better off you are in life, the longer you will live. But as statisticians, as actuaries, we want to quantify that statement, and we want to find out, how much different are the death rates for the most deprived compared to the death rates for the least deprived. And that actually brings me to my first opinion poll of this afternoon. This ratio, I show you the poll in a second, is about this ratio that we see here. So the number of deaths per 1,000 in the most deprived areas relative to the number of deaths per 1,000. I want to ask you, and on the next slide, there's the question, and I will give you some possible answers. So my first answer that I would give you here, want to give you, is the ratio is less than 1.5. So there's less than 50% extra mortality in the 10% most deprived areas relative to the 10% least deprived. Other possible answers would be the factors between 1.5 and 2, so between 50 and 100% extra mortality, between 2 and 3, or even up to 4. Yeah, so less than 4, but higher than 3. Okay. A bit of help we will find here. We have that in 2001, and we only talk, I should have said that maybe earlier, we only talk about the year 2001 year and age 65. And in that year at age 65, in the most deprived areas, we had 25.3 deaths per 1,000 lives on average. Okay, so the question is, how does that compare to the least deprived, and how does it compare, and what is the factor then? And I think we have some results. Gordon, is that correct?
We do indeed. I should have said at the start that to get to see the results, you do need to give a response. So if there's any late responders, now's your opportunity. But I think yes, we've got a very close answer, but we've got a winner.
Oh, we have 2 winners now, actually.
Oh, it's now a dead heat.
Yeah. So we have we have a winner now, which is between 1.5 and 2. So that would be answer B, but it's very close to answer C with 2 and 3. And what we found is actually the ratio is about 2.2. And so the number of deaths per 1,000 life is about 25 in the most deprived areas, and it's less than half of that. It's only 11 point something in the least deprived areas, so a ratio of around 2.2. Okay. We could look at other ages, of course. And here we have a graph of the LOC mortality rate at different ages in the year 2001. So we start here at the age of 40 and data go up to the age of 89, and what we find is, well, there are 2 striking features here. One is there's this huge difference in the mortality rates of the very young, the 40-year-olds, 50-year-olds, so very young in this group of individuals. And there's almost no mortality differential for the older ages, say 85 or 89. And clearly it shows that once people live to a certain age, like 85, 89 or so, the socioeconomic background is less important for their mortality than it is at age 50 or 60. But of course, in the most deprived areas, there are much fewer people living to that high age than in the least deprived areas. The second point I really want to mention here is that we see that the LOC mortality rates for the different IMDD sites, the different colors here represent different IMDD sites. The LOC mortality rates are all almost linear in age, a law which has been discovered about 150 years ago by Benjamin Gompertz, known as the Gompertz line, and that still seems to apply today. Okay. Now, very briefly, we compare those results that we just saw for males to females. Very, very similar. Very, very similar. We have at the old age, mortality differentials almost disappear, but at the young age there are substantial differences between those. Now, what we've seen so far was for the year 2001. All of those graphs are for the year 2001. Question is, how did things change over the 14 years from 2001 to 2015? And that brings me to the next poll. Same question. We are talking about the death rate at age 65, and we compare the number of deaths per 1,000 in the most deprived areas to the number of deaths per 1,000 in the least deprived areas, but we do that now in the year 2015 rather than 2001. So 14 years later, I give you the same 4 possible answers, I just remind you of what we found for 2001. This is the result here. And as a little help, maybe, what we found in 2015 is that in the most deprived areas, death rates have come down. So there is an improvement in mortality for the most deprived. The number of deaths has been reduced from 25 to 22 per 1,000 lives, which is great. Question is, has there been an improvement in the least deprived areas? Has that improvement been of a similar magnitude, or has it been stronger? And what is the ratio that then follows? And I think, again, we've got some answers. Is that right?
Yes.
Still changing, yeah?
Yes, it's still changing. 1 or 2 votes still coming in. I think we'll stop there, and we've got a dead heat.
Yes, it's just the answer B is again just winning. So that would suggest that the ratio has gone closer to 1, so that the improvements in the least deprived areas have been weaker than in the most deprived. But what is actually true is the exact opposite. What we find is that the ratio has gone up. So in 2015, the number of deaths per 1,000 in the most deprived areas has been more than 3 times as high than it has been in the least deprived areas, because in those least deprived areas, in those areas where people are best off, have the highest income, have the highest levels of education, people have experienced a spectacular, I would say, improvement in mortality, with numbers of deaths going down from 11.4 to 6.8. Not quite half, but a substantial improvement in mortality, and much stronger than in the most deprived areas in England. Right. Again, looking at the picture for other ages in 2015, very, very similar picture to what we've seen in 2001. So if we compare the two, there is a bit of a general downward shift. It's hard to see maybe in those two pictures, but there is a bit of a downward shift from 2001 to 2015, which is this general improvement over time. But also we see that there is now a bigger gap between, a bigger difference between the most deprived and the least deprived. And that difference still seems to be significant even at high ages. Yeah, so there's still a visible difference between LOC mortality rates at age 89 or 85 between those different socioeconomic groups, which is quite interesting. Just to complete our table here, give you a few more numbers. This is the developments that we have seen over time in 2005 and 2010. The ratio has gone up consistently over those 14 years from 2001 to 2015. Now, I'm not here to speculate about the reason offered in the media at some points, but I think it is very relevant, not just for public policy, it is relevant to look at those numbers. But I would also argue that it is relevant in particular for pension actuaries, because someone living in one of the least deprived areas in England is much more likely to have a sizable pension than someone who lives in the most deprived areas. So my guess is, in many pension funds, the biggest liabilities are associated with people who have very often say that pension actuaries might be ill-advised to use population mortality rates or population mortality projections. They should rather look at different socioeconomic groups, because those differences are substantial. I want to look a bit more at the development over time. So we pick out a specific age now, the age 65 that we looked at in our poll, and we look at the change in the mortality rate, or the death rate, the LOC mortality rate at age 65 over time. And what we see in the graph is, again, the very top line, the black line there, that is the mortality rate, or the LOC mortality rate, for people living in the most deprived areas in England. And the graph right at the bottom there, the grey line, is the mortality for those living in the least deprived areas. And we see, of course, it's the lowest, okay. But we also see that there is an improvement and that the improvement is stronger for those living in the least deprived areas. Okay, it's maybe a bit difficult to see in this picture because there are so many lines in it and they're all kind of on a different level. So for those of you who are familiar with the Lee-Carter model, you will know that the period effect in a Lee-Carter model is like a mortality index which applies to all ages in a certain sense. And we can standardize those period effects to all start at the same level, at 0 in this case, that's what I've chosen here, and see how different they behave over time. And again, we see this picture that on the very top, the black line, the 10% most deprived, and on the very bottom, the gray line, the 10% least deprived. And since 2011, a very well-known feature of the English mortality data is that since 2011, improvement rates have slowed down significantly. They came to a stop, as we see here, and there are no more improvements for the most deprived, but for the least deprived, there are still improvements. Those improvements are not as strong as they used to be until 2011, but there are still improvements. So again, takes that into account when you make your projections, I would argue. Okay. Now, the focus of the research that we undertake is clearly not just on describing the past and finding interesting facts about the past. We are mostly interested in developing models which allow us to at least simulate the future in a sense, to generate possible scenarios for future developments in mortality rates. So we are interested in stochastic mortality models, particular models which allow us to simultaneously generate scenarios for a number of populations. Like in this case, we have 10 groups, 10 different socioeconomic groups, and we don't just want to have a model which projects one of those groups. We want to have a model which projects all 10 of them simultaneously, taking into account dependencies between the different groups. And the way we go about it, just as a brief, so to say, teaser here, we consider the number of deaths to be a random variable with a Poisson distribution. As some of you might know that model. Okay, and the aim of the research is then to compare different models and develop maybe also new models for the force of mortality, MXTI. Okay, so we have a force of mortality for a specific age, specific year, specific IMD decile. Okay, and the models that we look at, they are all of a similar structure. Okay, and the structure is a generalization of the Lee-Carter model, and has been introduced 15 years ago by Renshaw and Haberman. And what we now do is we try to take this very general model, which we can fit to each IMD decile separately, and try to see which of those parameters are maybe not specific to the IMD decile. So these differences that we have seen in the death rate or in the forces of mortality between IMD deciles, in which of those parameters do they show up? Which of them have to be specific for the decile, and which of the parameters is common to all of those? And here are some suggestions which we tried. We looked at common age effects and so on and so forth. Okay. So this is our models, and I just want to make some final remarks here. We skipped the more specific research question. I just want to make some final remarks here about our conclusions, which we have drawn so far. And well, we've seen today, I think, also, I hope I convinced some of you at least, that there are significant differences between these socioeconomic groups as measured by the index of multiple deprivation. The differences are not just in the level of mortality, but the differences also exist in the improvement rates. So it's not just that the least deprived have the lowest mortality rates, they also have experienced the strongest improvement. In terms of the modeling, well, we find that models with a common age effect, they tend to do best. So it seems that the models that we are looking at, the parameters that pick up the differences between IMD deciles are the period effects, it's not the age effects. The age structures seem to be comparable among across IMD deciles. And finally, when we talk about English or England-Wales mortality data, we should mention a cohort effect. Now we find that cohort effects don't really contribute much to the goodness of fit of the model. Okay? And with that, I would like to finish, hand back to Gordon, who I think will invite people to ask some questions, I hope.
Yes, absolutely. And questions have been coming in as you've been talking, Torsten. There's a question bar on the bottom of your screen, unless you're in full screen mode. You can ask questions anonymously, or you can add your name if required. One thing I will say is we won't necessarily be able to answer all questions right now, but we will post responses to all questions posted on the website later on. So looking at the questions, one easy question for you, Torsten. Have you extended the analysis to Scotland, given where we're sitting?
No, we have not extended the analysis to Scotland. We currently don't have the mortality data for the different LSOAs in Scotland. Of course, you can look up the value of the Scottish index of multiple deprivation, which does exist. But we currently don't have the mortality data per IMD or SMIMD decile, and therefore we haven't done that analysis yet.
Okay, thank you. A slightly more tricky one. Do you think the slowdown exhibited in the UK rates is permanent?
That is a very tricky question.
That's a great question.
And the answer is I do not know. I don't know whether that is permanent or not. It looks that there is a significant slowdown. This is not just noise because it keeps going on for a number of years now. My general reaction to that question would be to consider different scenarios. I mean, we cannot just, if we only look at one projection and try to get that right, I think that will be very difficult and we might always get it wrong. So I think to acknowledge that there is uncertainty about mortality projections and use stochastic models to quantify the uncertainty and maybe use those quantifications then for value at risk calculations for annuity pricing and so. I think that's the way forward rather than trying to kind of explicitly say there is that downward trend will continue or not. And as I said, the downward trend is much stronger in the most deprived area than it is in the least deprived areas. And that, is also be taken into account.
That's fine. One other slightly easier question for you this time.
Thank you.
You have shown improvements at age 65. Do they vary much for other ages? Did you look at other ages as well?
The improvement rates, indeed, they vary across ages, but again, for those who are familiar with the Lee-Carter model, the period effect of the Lee-Carter model clearly shows those different improvements, and those apply to all ages, but again to a different level, of course, through the beta variable in the Lee-Carter model. I don't have the data here for every individual age, but in general, yes, there are improvements, and the improvements are stronger in the least deprived. Yeah, that's all I can say.
Thank you. Probably one more question I think we have time for. Obviously the IMD itself is a weighted average index made up of a number of different indicators, wealth, health,
Correct.
education, etc. Did you do any work looking at the relative importance? Were some of those indicators more predictive of future mortality than some others?
We are currently looking at exactly that. The focus of the research is shifting a bit away from the index of multiple deprivation towards individual components, and it turns out that income is so far, we would say income is the big driver that makes mortality rates different. Okay. The other issue with the IMD index is, of course, that part of it refers to health, and of course somebody who is in bad health is more likely to die early. Yeah, but it's part of the official index that the government produces, so we kept that in because we still think that even looking at those deciles, there's a lot to learn from the data. But yes, it's right, the individual components, they are important, and income turns out to be of particular importance to people's mortality rates.
Excellent. There are a few more questions on the list, but I'm afraid we do have to go to the next presentation, but we will respond to those on the website. So thank you. And with that, I'd like to hand over to George for the next presentation.
Thank you, Gordon. I'll just
oh yeah, of course.
have the pointer. Right, so my presentation is on critical illness insurance and related morbidity rates and trends. And by related morbidity trends, I mainly mean here cancer rates, as we will see later on in my presentation. I should say at the beginning that this is joint work with Chum Shao Ji, PhD student at Heriot-Watt University, and Aisha Arik, a postdoctoral researcher also at Heriot-Watt, and also with Dr. Rangel Dodd at Southampton. So I'll start with a general, perhaps a brief description of critical illness insurance. So critical illness insurance is the terminology that is used mainly in the UK and perhaps other parts of Europe. Depending on where you live in the world, there might be a different term used. So I think in the US, critical care insurance is the term sometimes used. In any case, critical illness insurance is a type of health insurance that pays a fixed amount of money on the diagnosis of a specific illness. And there's a list of illnesses that are actually covered by critical illness insurance. And you can see on my slide there, the most common one, the most common cause of critical illness claims is cancer. I have death on my slide there, which obviously is not an illness, but I'll come back to this. Heart attack and stroke are also quite common, and I have you can see on my slide there on the screen other illnesses that are covered as well. Going back to death being a cause of critical illness claim, it used to be the case, especially and particularly in the UK, that critical illness insurance was actually sold together with mortgages. Nowadays, it's I think even more common that it is sold as a rider together with life insurance. So what happens is, if policyholders decide to buy life insurance, then they are given the option to actually buy a critical illness insurance together with that. And that's what we call a fully accelerated policy. Full accelerated policy in the UK terminology again means a critical illness policy that includes insurance, life insurance includes death, in other words, as a cause of claim, as opposed to what I have on my slide there, a standalone policy which does not include death. Right, moving on to the data that we have used in this research. So the data, these are UK data, so data concerning the UK insured population. They were provided by the Continuous Mortality Investigation Assurances Committee. And as you can see on the screen, we have two data sets here, two different periods of time. The first one, the earlier data between 1999 and 2005. So we have claims that were actually settled within that period, and that was a number of just above 19,000 claims in those years. And then the second period between 2007 and 2010, about 20,500 claims settled in that period. The data in the earlier data set, the earlier period, are a little bit more detailed. So we have almost per policy data, as opposed to the second time period that I have here, for which the data are the claims are actually grouped for different for various characteristics. One other thing that you will notice from those numbers perhaps is that since the first period that I have there has 7 years in it, the second one has 4 years, the per year number of claims is higher in the most recent data. So staying with the data, so this table here shows you the kind of the information that we have available in the data. So obviously we have the number of claims and the corresponding exposures, but we also have a number of risk factors that we are going to use later on for the, as you will see, for the model that we're going to build. And the model is for actually fitting and predicting claim rates for critical illness insurance. I'm not going to go through all of them. I'll just concentrate on perhaps the 3 ones that I have in red, which were present in the earlier data but not available in the more recent data. So starting with office, that means the company that actually sold, through which the policy was sold. That was we had that information anonymized in the earlier data, but not in the recent data. Further down on my list there, the cause of claim, again not available in the most recent data, and that is quite important for many reasons, but well, including what I'm going to talk about in the second part of my talk today, which is the cancer rates. So knowing the cause of the claim for critical illness helps us with various things, including what we have done here, the research that we have done here. And the last thing that I have highlighted on this screen, the date of diagnosis, again only available in the earlier data. This date is very important because diagnosis is actually the insured event. That's what people are insured for, the diagnosis of an illness. Having this date helped us with the earlier data to have some more detailed analysis, some more detailed models, including again some analysis that we did on actually the delay period, the time between diagnosis of an illness and settlement of the corresponding claim. I'll say just a little bit more about that in a minute. Staying with the data, so what you can see on this screen is data in 2007 and between 2007 and 2010, the distribution of the data according to different characteristics. Just to highlight the smoking status, the second pie chart, if you like, at the top there. 3/4 of the claims, so this is claims data, so 3/4 of the claims come from non-smokers. The third one on the top, benefit type, that's the green wedge there shows you that about 90% of the claims actually came from concern accelerated policies. Again, that means that these are policies that actually include life insurance. Just move on to the next one. Again, with the data here, what we have on this slide is actually the distribution. Well, it's a comparison of the distribution of the data for gender, smoking status, and age for the 2 different time periods that I have here. So the green bars there are for the more recent data. The blue ones are for the earlier data, if you like. And the important message, perhaps, here is that the distribution of the claims according to gender, smoking status, and age is quite similar in the 2 different time periods. So the distribution of the claims itself is quite similar according to the characteristics, but according to these characteristics. But what I really want to find out here, what this research is about, is it's about the claim rates. So we want to compare the claim rates in the earlier period to the claim rates to the later period, if you like, and see if there are any differences in those rates. And that actually brings me to the third pole of this session. So if we're looking at, remember we're talking about UK critical illness insurance claims. So if we look at the claim rates in 2007 and between 2007 and 2010, and we compare them to the rates in the earlier data between 1999 and 2005, have these rates, have the more recent rates, have they gone considerably up? Have they gone down? Have they stayed roughly the same? Or perhaps you have the option to answer that you don't know the answer. I think I do have the answer a bit later on my slide, so I think I can actually move on to the next slide, and then we'll see the answer in a few minutes. So in order to answer that question, what we have done here is we have fitted Bayesian stochastic models, and in these we have included the risk factors that I showed you in the a couple of slides ago. So before I go on to that part of the modeling, just very briefly to mention again the delay, the time between the diagnosis and the settlement of a claim. The earlier data have shown us that there is a delay between those two events, which is quite important. We didn't have the data to model that, the information to model that in the more recent period, but we did that for the earlier data, and we found some significant results. But I'm not going to talk more about this today. Let me move on to the modeling for the claim rates themselves. So very similar to the model that Torsten had earlier on. This is a Poisson model for the number of claims now. I'm not going to say too much about the equation that I have highlighted in red, so that's an adjusted exposure. The important thing here is the lambda parameter, the lambda rate, so that gives you the rate, the claims rate in this case. It can be particular to, so lambda j, particular to a cause j, and for at age x and other factors theta. And consistent with the Bayesian approach we have followed here, this can have a prior distribution and so on. And I think I'm ready now to, perhaps not yet, actually, one more slide before I show you the answer to my question. So we did that, and we found that a number of factors are actually significant in determining what the claim rates are in the most recent data. So just briefly on the right-hand side of your screen there, you can see that age is a significant factor. Older policyholders give higher claim rates. Smokers also. At the bottom of that list, you have again the policy duration, longer policy durations giving higher claim rates as well. So I think I'm ready now to give the answer to the poll question. So looking at the results here, and we have an overwhelming result here. 75% of you have actually said that the rates have gone up, and that's actually the correct answer. So well done, everybody. So you can see the graph that shows the answer actually. Just let me explain what the graph is about. So we have the for a specific scenario profile, if you like, of a policyholder. So for accelerated policies, smokers, policy duration 1. What you can see is the logarithm of the rate on the y-axis, and on the x-axis is age. The green dots there are the crude rates for the most recent period. The line going through those dots, blue and green, I think, shows you the fitted line, the fitted values for the most recent data. And the red line shows you the fitted claim rates for the earlier period, the 1999 to 2005 period. So clear from that, I think it's clear from that graph here that claim rates have gone considerably up, especially for younger ages. So this is a particular profile, as I said, for smokers, policy duration 1 and so on. But the picture is very similar. The results are very, very similar if we look at other profiles. I'm not going to show you more profiles just now, but as I say, the results are very, very similar. So I'm going to move on to the second part, if you like, of my of this research and of my talk today, which focuses on cancer incidence rates. And we're focusing on cancer here because, well, for many reasons, but one reason associated with the first part of my talk is that cancer actually causes about half, 50% of the claims of critical illness insurance claims in the UK. So very important for critical illness insurance. Now, what you can see on this slide is UK population cancer rates, and that refers to the general population. So this is not about insured lives, this is about the general population. The data come from the Office for National Statistics. You can see all cancers. The two graphs correspond to males and females. On the x-axis now you have time, year. So we can see how incidence rates for cancer change through time, through calendar time if you like, for males and females. And I have just chosen for illustration today 3 different ages, the red, green and blue, corresponding to ages 52, 57 and 62. Again, the dots on the graph show you crude rates, incidence rate, observed rates if you like, whereas the lines and the probability intervals show you the fitted lines, the fitted values from our Bayesian models. So one thing we can see is that the rates are, cancer rates for the general population are increasing with time. We can see the increasing trend. You can also see that the rates are actually higher for older ages. So remember, this is for the general population. And what I want to do and what we did next is to try to link that and compare that to what happens to the insured population. So here comes my second poll or fourth poll of this session. So now, if we think about the insured population cancer rates, so cancer rates in the insured population in the period between 1999 and 2005, compare those to the general population cancer rates. So do you think that those two sets of rates are at the same level? Do you think that the insured population rates are higher, or do you think they are lower? Or perhaps you don't know the answer. Right, I think I have now the answer on my next slide, so perhaps we can wait for a minute or two until we show the answer here. So I can see there are some results already coming in.
Starting to come in. Need a few more to get a definitive response though.
Okay, I can see that the lead is not changing, but well, perhaps it is changing. I can see some variation in the answers already. Right, okay, so I don't know if Gordon or Torsten, if you have a view on this, or...
Well, I'm afraid I've seen the answer already, so I really can't say it. I don't want to introduce any bias to the remaining responses. I think we're pretty well there, though. That's a good number of responses. Thank you, everybody, for participating.
Okay, good. So I can show you the answer on the next slide, and I will explain the answer just now. Looking at the poll results, the lead is for the lead answer is that the insured rates are considerably lower, which is actually the correct answer. As you can see there from on your screen from the plot. Now we have for male policy holders, you can see two sets of lines there on the graph. The solid lines are the population rates, and the dashed lines are the insurance population, the insured population rates. Again, for the 3 age groups that I had on my previous slide. So if you just look at the top there, the blue lines, that's for the age 62, you can see that the insured population rates are much, much lower than the general population rates by a factor of, I think it's between 2 and 2.5. So that's the general message. The obvious question then is, why is this happening? And I don't have the definitive answer to that, but one possible reason for that could be that, well, it could be the differences between those who can actually afford to buy critical illness insurance and those who cannot afford to buy critical illness insurance. This is, though, making an assumption that answer is making an assumption that the rates, that cancer rates are actually lower in the most affluent groups in the population, which might be true for some cancers, but not all cancers. So, as I said, I don't have the definitive answer, but it's definitely something that we want to think about in that respect. Let me show you the corresponding rates for female policy holders. You can see the picture is the message is the same, that insured population rates are considerably lower. But you can probably see that the gap is narrowing. The gap is now narrower between population and general population and insured population rates. And if you look at my second comment there, is that could that be the effect of breast cancer? And actually, this goes back to what I was saying just a minute ago, that the most affluent groups in the population in the general population having lower cancer rates might be true, but it's not true for all cancers, and that's definitely not true for breast cancer, which doesn't distinguish between different socioeconomic groups, and that could account here for the gap closing when we're talking about females. The other feature that I want to perhaps focus a little bit on, and that's I think my last slide, is well, when we compare when we want to compare the rates between the general population and the critical illness population, the insured population, we need to keep in mind that not all cancers are actually covered by critical illness insurance. So there are certain types of cancer that are not covered, and if we want to make a fair comparison between the rates, we need to exclude those. That's not very easy to do in practice because we don't have all the information that we want in the data. But one thing that we could do and did here is to exclude from the general population rates, we excluded melanoma skin cancer, which is one type of cancer that is not included in critical illness insurance. And the graph you can see here is for females with the general population rates excluding skin cancer. And you can see again, perhaps that the gap is even narrower now, as you might expect. But I think the most interesting thing here on this slide is actually that the trend seems now to be different between the general population rates and the insured population rates. Perhaps we can see on this slide that the rates for the insured population are increasing faster than the rates for the general population, and that's a very important message, I think, for insurers. I think I'll stop here. I'll just go through a couple of points from my summary. Just focus perhaps on the points that I have in bold there, in bold type. So one message, perhaps important message here, is that the claim rates, critical illness insurance claim rates are going up according to our analysis with time. And the second important message is that the cancer rates for the insured population are much lower than the cancer rates in the general population, but perhaps there's a different trend which could be worse for the insured population. I think I'll stop here. Gordon?
Okay, thank you, George, for that, and please do keep them coming. First one for you. Cancer rates are lower for the insured population. Well, we've seen that in the data, but the commentator says, I think the converse is true for developing countries, where cancer tends to be more of a lifestyle disease. Is that something you've observed in data from other countries?
That's a very good point, and that might, I think it's probably true for other countries. We haven't looked at data from other countries, so as I said, I suspect that this is true if we look at different parts of the world. The point about lifestyle cancers is very important here because this is what makes the difference. I talked about breast cancer before, not distinguishing between socioeconomic groups. This is definitely not a lifestyle type of cancer, but other cancers will have different trends there.
Will certainly be, yeah. One question about the differences in the data collected between your earlier and later periods. One commentator asking, why were the cause and the diagnosis not available in the later set? Was there a reason for that change in approach?
Okay, so to start with, the data were collected, both sets of data were collected from, by the CMI, the Continuous Mortality Investigation. And as far as I know, the methodology for collecting the data, or their approach to collecting the data, was the same. I think it mostly has to do with the offices not providing those particular pieces of information. To be more precise, I think that some of the information that we don't have available in the more recent data was provided, but not in a complete form, not in a form that we could then use for our analysis. So both the CMI and ourselves decided at the end.
Yes, postcode lottery. Mm-hmm. Should geographical area be a key risk factor?
That's a very, very good comment, and it actually well, I can give you the answer in the if there is one a similar event in a few months' time, because we are now starting to look at those geographical regions, different geographical regions. We have the data from the ONS on different geographical regions for cancer now, and we are looking at extending our analysis to different to include geographical area as a factor in our model. So I think it will actually, and I hope it will produce this analysis, this new piece of work will produce some exciting talk a bit more about.
Critical illness is all about incidence rather than actual survival. So
that's correct. That's
not clear there will be much difference, but I look forward to the research, George. A couple more questions. We do have 2 or 3 more minutes. Any confounding with the statistics with changes either in the range of illnesses covered or perhaps underwriting practices over time?
Yeah, this is something, again, another good question here. Again, the good news here is that we are and have relied on the CMI providing the data to sort of sort out these different problems that might have to do with different definitions of illnesses and so on. But the truth is that definitions are changing. Not only definitions of illnesses are changing, there are medical advances that make it more challenging to make sure that we are talking about the same diagnosis of the same event. The other thing that is related to that is that different illnesses are included in policies in different parts of the world. Of course, here we only looked at UK data, so that was not an issue with this analysis. But going back to the question, we, as I said, we relied on the definitions being as much as possible consistent between the 2 different data sets, and we didn't account for that in the actual modeling. But
Sure.
we did go back to the CMI when we first looked at the data, try to make sure that the definitions are as and the different illnesses are as consistent as possible before we could do the analysis. So my quick answer would be that there shouldn't be any significant problems in the analysis because of that, but definitely the definitions are changing, and this is something we need to take into account in the future as well.
Good. Thanks, George. I'm afraid we have time for one last question, which is the lower rate observed for the insured population. Did you consider the extent to which that might be caused by the initial selection effects of underwriting in the life offices?
That could have been a factor as well, but I suspect we couldn't look at that very in detail in our in the data or in the model for many reasons, confidentiality purposes reasons as well. We offices well, we didn't have the office information in some of the data, but again, I wouldn't want to speculate, but if I had to give an answer, that would be that I think that it's not mostly because of that. I think mainly because of differences between the insured population and the general population. But underwriting could perhaps have a small part again. A small part as well. Yeah.
Thank you, George. Now I'm just going to do a couple of closing remarks. Word cloud come up on your screens. We'd quite like a little bit of informal feedback. So while I do my closing remarks, perhaps you could type in 1 or 2 words that you think of that best describe the program, the seminar you've just been watching. So I'll leave that open, and if you could put something down. And I think all that remains for me is to thank all of you for, first of all, attending, but also participating in the Q&As. And a very big thank you to our presenters, Torsten and George, for interesting presentations. Thank you both very much. We would love to have your feedback. So again, there will be a form found on the website. So thank you for that. There'll be an online survey. There's also a video of this seminar will be posted on the IFOA website. So again, if you want to recap or bring it to the attention of some of your colleagues, that would be terrific. And we look forward to seeing you again in the 2019 webinar series.